Hello everyone, I am Aman back with another beautiful problem on BST. So problem name is recover binary search tree. We are given a BST. Again, what is the property of BST? For every node, all the nodes on the left subtree will be smaller, all the nodes on the right subtree will be greater. This property is true for all the nodes. Now, what they have done in the question, they have chosen any two random nodes and they have swapped their values. So let's just say this is a BST that I have in front of me. What they have done, they have, let's just say they randomly chose these two nodes and this is what they have done, swapped them. Now I have to identify these two nodes. Okay, so this is what is given to us as an input and we have to figure out these two nodes. Now the problem is very simple, to be very honest. What do we know? We know in order of a binary search tree sorted. So if, let's just say, if this is what is given to us as an input. If, let's just say, instead of this I would have got the original BST, then this is its in order, correct? Now what they have done, they have actually swapped the two values. So instead of this, how I will get in order is, I'll get the in order in this format. I'll get 9 here and I'll get 14 here. Now I have to identify these two nodes, correct? Now very easy, it's not that hard to imagine, simple. The question is actually nothing but we are given an array, sorted array, in which two values are swapped. You have to identify those two values. Now how hard it is to find these two values? So simple, let's just take let's just understand it case by case basis. Let's just say if this was an sorted array initially, so that's how its curve should have been. I mean, every index is greater than the previous index and smaller than the next index, right? Now they have randomly chosen two values. Let's just say second index and fourth index, and they have swapped them out. So this is how my sorted array looks right now. I mean, this is the best way to understand. If I do it via values, you won't understand nothing. Now I'll try to do the same. So I will start with the first index. I will check, am I greater than the previous guy? Yes, I'm greater than the previous guy. It means nothing is problematic here. This time at index 2, am I greater than the previous guy? Yes, so nothing is problematic here. Now this place, am I greater than the previous guy? Obviously not. I'm not greater than the previous guy. At this point, array of I is less than array of I minus 1, which simply means what? This is a problematic place. Now in this problematic place, you can see in diagram, out of array and I and array of I minus 1, which is the problematic element? So in this case, we can clearly see array of what? I am at the third index, right? This second index is the problematic element. So first time this occurs, when first time this occurs, simple, first element is first, or may I call it problem 1. Problem 1 is array of I. Now let's go ahead. At this place, current element is again, now at third index, I was not greater than the previous guy. At fourth index also, I'm not greater than the previous guy. So second time this issue occur. Now when this time this issue occurs among these two elements, 4 and 3, which is the problematic one? Obviously this element is the problematic one, right? I mean, let me highlight the problematic ones here also. These are the problematic ones. So first time when I was at third index, this issue happened. So we said I am at I minus 1th guy is the problematic one. When I reached here at this index, again this problem occurred, that I'm not greater than the previous guy. So this time array of I is the problematic one. So second time this issue happens, second time this happens, so we can get problem 2, but this time problem 2 is array of I. Now let's try to understand it via an example, what we did just now. So I'll keep on traveling. Array of I is greater than array of I minus 1. Array of I still greater than, array of I still greater than array of I minus 1. This time I'm not greater than the previous guy. When I'm not greater than the previous guy and first time this is happening, who is the problematic element? The current element. Oh, sorry. In this case, it is array of I minus 1. Right? When first time this issue happened here, when I was not greater than the previous guy, array of I minus 1 was the problematic one. So who is the problematic one? 14 is the problematic one. So first issue I identified. Now let's go ahead. I'm still greater than the previous guy. This time I'm not greater than the previous guy. So second time this issue happened. When second time this happens, who is the problematic guy? The current element. So that's how I'm able to identify both the elements. Now, when this is clear, there is one more edge case to that. The case 2 is when they swap two adjacent elements. So let's just say they swap these two elements. So you can see the swapping here. Now this time what will happen? Here I am greater than the previous guy, here I am greater than the previous guy, here I am greater than the previous guy, here I am not greater than the previous guy. So first time issue happened. When first time issue happens, what we say? First element is array of I minus 1. But what will happen? This issue is never going to repeat again, right? It will never happen again. I mean, here it happened that I am not greater than the previous guy. So we said first element is array of I minus 1, which is true. But again, it will not happen. I am greater than the previous guy here also. So what will you do when first time the issue occurs? You will say that I don't know if two adjacent elements are swapped or two distant elements are swapped. So first time this issue occurs when I am here, I am not greater than my previous guy. So simple, I will say first issue is array of I minus 1, second issue is array of I. Now, if I find the second issue anywhere else, I will update the second element. That's how I'm going to do it. So let's just see it by an example. So this was, let's just say, in order of a sorted in order of a BST which is sorted. Let's just swap two adjacent elements. So let's go. I am greater than the previous guy. I'm greater than the previous guy. I'm greater than the previous guy. Still greater than the previous guy. This time I'm not greater than the previous guy. And this issue is coming for the first time. Since this issue is coming for the first time, I will say my problem 1 is nothing but array of I minus 1, which is 13. And my problem 2 is what? The current element 10. Now, if I find the issue again, I will update my problem number 2. So if I go ahead, I'm greater than the previous guy, greater. So I never found the problem again. If I would have found the problem again, I would have updated problem 2. So this is how I handle both the cases. Now, to apply this approach, what you will do, you will create the in order array out of this BST. We can save creating this in order array. Okay. Why? Because when we traverse a BST in order, I mean, to apply this approach, what do I need? I just always need to compare myself with the previous element. When I do in order of a BST, actually I am traversing the BST in a sorted format. So I always have the previous access. I will maintain a global previous, and that's how I'm going to do it. Let's just see it here. So initially, my previous is null. Okay, and let's just start traversing. So I reach this 3. 3 is the first element from which I am coming back from the left. Left side is null. So I will make myself as the previous. First of all, let's just say we reach 3. First element that will reach in order is 3. Now I will compare myself with the previous guy. Previous guy is null. So I cannot compare myself. I'm the 0th index. Okay. And now before going ahead, let's update myself from the as the previous for the next guy. Now we go ahead. I reached 5. I'm at 5. Am I greater than my previous element? Yes, I have the previous element now in the previous variable. Am I greater than? So there is no problem. Now before going ahead, I'll update the previous to 5. Now let's go ahead. The next in order element that you will find is 7. You reach 7. Are you greater than the previous guy? Yes. So let's update the previous and let's go ahead. Now I reached 14. Am I greater than the previous guy? Yes, I am greater than the previous guy. So there is no problem here. Let's update myself. Now let's go ahead to the next place. I reach the next place 10. Am I greater than the previous guy? No, I'm not greater than the previous guy. And the issue is coming for the first time. So first time this issue occurs and I'm not greater than the previous guy. So we say what? First element is the previous element and second element is the current element. So I know what? Problem 1 is 14. I update problem 2 as 10. Correct? Now let's go ahead and update previous to 10. Now I go ahead. Next element I found is 13. I'm greater than 3, so not a problem. Next element I found is 9. Am I? And previously we will update the previous also, right? When we were going from 13 to 9, we'll update the previous also. Now here I reached out to 9. Am I greater than the previous guy? No, I am not. So this issue is coming for the second time. Now when second time issue occurs, who is the problematic element? The current element is the problematic element, and I will update my problem 2 as 9. So this way now I will never find a problem again, because after 9 I will update previous as 9, and for further elements I will always find I am greater than the previous guy. And I am able to maintain the case also when two consecutive elements are swapped. because first time the issue occurs, I update both problem 1 and problem 2. If second time issue occurs, I update problem 2 again. So let's just quickly code it up. So I've created problem 1, problem 2 and previous. Initially, all these three are null. Simple. And what do I have to do? I have to do in order traversal. So simply, when I am at 10, I want the previous, or let's just say it here. When I am at 5, I want the previous to be storing 3. So first I have to come back from left, right? So first I will make the left call, helper, root dot left. Then what? Simple. Now this is the situation that somebody has reached out from the left. So for example, if I'm at 10, my left call has been completed. Now my previous is storing this guy 14. So I want to compare myself with it, right? Whether I'm greater than the previous guy or not. But previous is initially null and I don't want this comparison to happen for the first guy, correct? So you will say if previous is not equal to null, because if previous is null, it means you are at the first node. There you don't want any comparison. And I am greater than the previous guy. It simply means what? There is a problem. Now, if the problem is coming for the first time, this problem 1 variable would be null. So if problem 1 is double equals to null, it means problem is coming for the first time. Let's update problem 1 and problem 2. So when first time issue occurs, what have we planned? When first time issue occurs, we will update problem 1 as the previous element and problem 2 as the current element. So simple. Let's just compare this with previous dot value. Now I'll simply say problem 1 is equal to previous guy and problem 2 is equal to current guy. Now if again it happened that I am smaller than the previous guy, but problem 1 is not null, it means the problem is occurring for the second time, because first time it's already been updated. So in this case, I will simply update my problem 2 only. So problem 2 will become what? The current root element. And that's how it will end. At the end, now I have completed myself. Now I'm going to go to the right side. So before going to the right side, what do you have to do? You have to update previous with yourself and then call the right side. I mean, this is what you want, right? What we want, that from 10, when I'm going to the right side, the first element that I'll reach is 9. For them, previous should be me. So that will be all for this problem. And the base case would be there. Base case is obviously if root is null, in return, in that case, we don't want to do anything. So now I have both the problems or both the elements, both the nodes stored in my problem 1 and problem 2 variable. Time complexity is, since I'm traversing over the whole tree, it's order of n. Space is just the recursive stack space, which happens via in order. I mean, if you look at the code, this all is constant operation, right? This is all constant operation. So what are you doing? You're just simply doing in order. So we know the time and space for that. Time complexity in that case is order of n and space complexity is order of h. So that will be all for this problem. Thank you so much everyone. Hope you understood everything. Bye bye. See you.